Hello YouTube, RJ. Hey, got a new package on the bench, a new tool for the lab. So let me get this this opened up and let's take a look at what we got today. All right, so me and my helper up here on the bench, we've got the bag open, and the model is an MDL-150, made in the big how do you pronounce that? Anyway, that place overseas. And let's take a look at what it is and what we got. We got it's a DC 0 to 150 volt, DC 0 to 20 amp, 0 to 150 watt something. So what do we got? We got something in here. What do you think's in here, Aiden? What do we got? You don't know. Look, it's a wall wart. We got a wall wart. All right. So we got a wall wart. It's a 50 or 60 hertz, 100 to 240 volt AC, 12 volt out, 1 amp. Okay. And it's your typical, really cheap, got LED, feels like, you know, there's no transformer, really, really light. So let's get this out of the box. Oh, dang it. Yeah, look what's in there. And as I figured in the imagery, it looked bigger on the AliExpress site, but this is a electronic load. And I have electronic load. Give me just a second to reach up here. Let me show you. I have an electronic load. This is my electronic load I've been using. But this electronic load here, very inexpensive. I only paid, I don't know, $19 if I remember right. It was really, really cheap a long time ago. I've used it a number of times. It works. It's limited in its voltage. As I remember, I believe it's limited to 30 volts. It's only able to handle like an amp, depending on the voltage, because it's really by the wattage. But as I remember, it's able to handle, I want to say like an amp of current. It's pretty limited, but it does work. It doesn't work well, actually. It's quite useful. It has a wall wart just like this. Little fan heat sink. This is a little better packaged one. This one is substantially more capable, as we were looking at. You can go up to 150 volts instead of 30, which is nice. Instead of 1 amp, you can go up to 20 amps. It runs on 12 volts, 1 amp power supply needed, load voltage DC 0 to 170, load current DC 0 to 20 amp, load power is a max of 150, maximum load capacity of 60 watts above 120 volt. Instead of having this little interface, it's got a similar input here, but a lot more information. It also has thermocoupler. So if you're testing batteries or something and you want to limit the temperature it can get to, you can use the thermocoupler to do that. With that, we'll jump over. I'll get this power supply unwound, and we'll actually hook this up and take a look at it. Turn it on, take a look at it. Screen, I don't know if there's a protection on it or not, but it's kind of scratched. I'm trying to see if doesn't really seem like there's a screen protector on it. It's kind of scratched up a little, so you got that going on. The case isn't too bad. It's powder coated, I believe. It looks pretty good. You've got screw-in terminal connectors here to make your connections. Got a decent sized fan on the back. I think it's just a heavy-duty one of these in a metal case, really, but definitely got more heat sinking in there from what I can see. It'll be interesting to see how it does. Let me get it rigged up a little and we'll give it a go. So give me a few minutes. I'll be back. Okay, so I've set up to do a little quick test of this unit. The first thing that you need to realize is this is set up originally as a 4-wire. You have your voltage here and your current here. In my case, the voltage and current are coming from the same readings. So I've just used 2 wires and connect them. It says the way it's worded in here says wiring method is A+, V+, V-, A-, 4-wire system, downward compatible with 2-wire system. I haven't quite figured out how you downward compatible it to 2-wire system, but I understand why they're doing this. If you're pulling a big amount of current and you're wanting to accurately monitor the voltage of, say, a battery pack or whatever, having separate wires here for the voltage is helpful because you're not pulling current, so you don't get a false reading. So kind of a nice feature. What you could do is just jumper these together, and that would alleviate that. I think what they're getting at is there's two currents. Current positive is here first and second. Current negative is the last post and the next one to it, and then your voltage is in the middle. So it makes sense to me that if we jumpered the voltage to the center post or to the second post, and over here the negative voltage to the second to the last post here, just putting a jumper here and here would mean you would hook one time. So if you want to do just a single wire or two wire measurements, that's simple. Put a jumper there, you're good to go. So anyway, what I've got set up here is I've got my little O1 power supply here set up with 60 volts, 2.5 amp max. I've got the little MDL-150 electronic load set up. All I've done is went and told it to set the current. I'm on constant current mode, 2 amps. As you can see, you get a lot of information here. You get the inside temperature, you get the outside temperature of this thermocoupler. It comes out right here. So you can put this on a battery pack or whatever, monitor stuff to make sure things don't overheat. And these can be set to stop it from outputting. If it starts to overheat or your battery pack stops to overheat, what you do is you go down and set the maximum temperature for this, which I haven't quite figured out how you do that yet, but it's there. You've also got the ability to set to constant voltage. In fact, let's take a look here and see if I can. It's in constant current right now. You get this blinking, it's constant current right here. If I turn it constant power, now I set how many watts max I want to pull continuously. Constant resistance, you can set an ohms reading here, setting here, and have it act like a resistor. So I've got it in constant current. I'm saying pull 2 amps. So right now, if I turn my power supply on, you can see it's not pulling anything. You can see it recognizes there's 60.01 volts here, but it's not pulling anything because I've not turned it on to run. It's in stop at the moment. So if I hit run, we should power and start pulling 2 amps from this power supply continuously. Oh, I had to exit the menu. I'm out now. Push again. It's on. I'm pulling 2 amps from a power supply. If we watch the inside temperature over time, it'll start to climb as you can see how much I'm pulling. 119.82 watts, which is maxes out at 150 watts. 2 amps, 59.91 out of the power supply, it says. You can see the charting on the power supply show that we're pretty steady current voltage. It's counting up my watt hours that I've pulled. If you want to do battery tests, you've got that going here. You can hear the fan whining. The fan does not come on by temperature. It comes on the moment you turn it on. I don't know if it ramps up or down with temperature at this point, but it sounds like it's running wide open at the moment. We're starting at 36.4.5. We're starting to warm up inside. This temperature is not changed because the outside temperature hasn't changed. Here you've got your over voltage protection, your over current protection, and your over power protection. These are set for 150 volts, 20 amps, and 150 watts. So if you try to exceed that, this thing will stop. It won't let you do that. This tells you how many amp hours capacity it has. So as you run a battery down, what you do is you set a stop voltage right here, the lowest you want your battery pack to get down to. You reset this, and when you start the test at whatever load, it's going to count up how many amp hours that battery had. So that's what it's useful for. A lot of good information here on the screen. There's don't know if you can make it out here or not, but there's actually a time setting. You can go in and set it and say, I want you to do this for 20 minutes and stop, and it will stop. So far, I like it. It's up to 40.8. I'm not at the max 150, but I am pulling 120 watts. And I can feel some heat coming out. We're up to 41.1 degrees C. Already this is the max voltage that this supply will provide. You can see that I'm pulling 2 amps at 60 volts. I'm so far over my little unit that I showed you what it can do. So we can test that it works the way it's supposed to by simply, let me turn down the voltage here. Okay, we're going to start cranking down the voltage, see if we continue to take 2 amps no matter what I do with the voltage. Yeah, I'm down to 23 volts, still pulling 2 amps. 45 watts. So that's working correctly. So let's stop it. And let's go into messed up. Got to catch it just right. Got to get down to where this blinks. See it's blinking? See, once the temperature's down to a certain point, the fan cuts off. Let's do a constant power. Let's tell it to get back to the right place. Still figuring this menu system out. There it is. Let's tell it to pull 10 watts no matter what. So if I do that, okay, I'm pulling 9.948 watts right now. So if I was to change my voltage, I should still going up, should settle back to 10 watts each time. Well, apparently that fan is temperature controlled because right now it's not running. I'm at 60 volts now, still pulling 10 watts. So my voltage is 60, my current's 0.163 amps, I'm getting 9.780 watts. So not perfectly 10 watts, but pretty close. Tells me that to do that, it's using a resistance of 368.098 ohms. So that appears to work just fine. Turn the voltage down. Let's turn it way down. There's 7 volts. And she's settling about 10 watts. So this is going to take a little getting used to. It's not, not the easiest. You have to watch and it doesn't instantly update as you push the button. You have to push, wait a second, see what it's doing, what it's asking for. So again, the run stop button, let's stop it. It's in stop. Very interesting little device. Obviously a little heavier duty than my other one. I can see it being handy. A lot of nice information here. Seems to work okay. I really won't be able to tell more until I've used it some more, but the fan is running very, very slow, moving just a little heat out of it. Most of what you're hearing is this thing. Let's try resistance. What if we told it to be a 50 ohm resistor? Let's try this set constant resistance. So it's going to be a 50 ohm resistor. What's that going to be? at 60 volts. 1.204 amps. Both of them are pretty close to matching. Okay, one other thing I hadn't tried I wanted to get on video here is there is this stop voltage. So if you're discharging a battery and you want it to get to a certain voltage and stop, it's supposed to stop and not over discharge your battery, and then that gives you the watt hour count. It's counting up your watt hours and stuff. And you reset this in the menu. You go in the menu and reset. So I wanted to try this. I've set it to stop at 11 volts. So let's pull 2 amps. We're at 60 volts again. I'll start turning the voltage down, and we'll get down, and when we hit 11, let's see if this thing stops. Okay, we're pulling our 2 amps, 60 volts. I'm going to go in and start turning my voltage down. Okay, coming up on 20. There's 20, 19, 18 volts, 17 volts, 16, 15, 14, 13, 11. One more click should take me under 11. This thing should kick out. Ready? And click now. Yes, pretty quickly it did it. That works fine. That doesn't have any bugs or whatever in it. I would say things look pretty good. There's an extra little hole for a switch or something back here. I don't know why they left that. Maybe that just one case and they do multiple things. Be nice to see a grommet in this hole right here. I will say that. And I might be able to squeeze a grommet over this sensor and in there. I might try that. Something I didn't show you is to hook your wires up and stuff. This pulls loose. This terminal strip comes out. You just wiggle it out. Allows you to hook up. Here's your markings down here for what's what. You can pull this off, connect it up what you need to connect to, and plug back in. And if you damage this, you can replace it. So it looks like a totally straightforward terminal strip. I really can't say a whole lot more. I mean, the screen was it's got little fine scratches in it. They don't have a screen protector that I can tell. If it is, I haven't been able to get an edge and find the plastic. It kind of looks like it does, but I think it does. Let's play here. Hopefully I'm not screwing my screen up. I think it does. I think that's why the screen looks like it does. It does. It has a protector on there. Hang on. Let me get something to get that out. Yeah, they put the benzol on after they put over the screen, and the plastic was on the screen when they put it in. So it makes it a little difficult to get off, but that's it. That's all I've got. I don't like the way they stuck the plastic under this. I like to see a rubber grommet here to keep this wire from chafing over time, and I hope doesn't feel like it, but I hope there's a strain relief of some kind in there. That'd be nice. I think the next thing we need to do is tear this apart, take a look inside. I'm sure y'all are interested in what it looks like inside. I want to see what the build looks like. Let me get this thing partially tore apart. We'll take a look at it after I get the bench cleaned off. Okay, I've got the top off. Let's take a look at what we got here. There is no strain relief whatsoever on this. It's just a JST plug on the board. So maybe what I'll do is tie a little knot in there to strain relief it, and maybe see if I can get a grommet in there from my kit. One thing I noticed a little not riled about is, can you see right here, you've got your shunt, your resistor shunts that are going to get hot. This wire can easily get up in here. Helps me get where you see it. This wire right here can easily get into those. So this definitely needs to be like a knot put in it or whatever to hold it over here to make sure that we don't mess around with this and pull this into that, which could get hot enough to damage the wiring. The screen's all an integrated system with one JST here that you could release and pop this screen out, including the encoder. The board is very straightforward. Got some pretty high current traces, as you can see here, through these shunts. Pretty decent size heatsink, substantially more than my little one. The build isn't horrible. I'd like to see a couple things. One is this wire right here is probably just fine since there's nothing getting up into it. I guess that's probably all right. I don't see it getting damaged. This is not a sharp edge. I'm sorry. This wire here I'm talking about. There's no load on it. Nothing's going to be pulling it or moving it. Fits down in there. There's no edge along here. It's powder coated, very smooth and rounded. So I think that's probably okay. First look at it, I thought, oh, the fan I'm sure is not the highest quality you've ever seen. It's a CJY brushless DC fan, 12 volts, 0.20 amp. I'm sure that's super high quality, but it looks like a standard size fan. We could put a nicer, newer fan on here if we wanted to do that and quiet it down. You got some, see if we can make out these capacitors down in here. I can tell you a little about them. They are Chongx. Oh, yeah, that's probably one of those fine Chongx capacitors. I'm sure that's top of the line. Kind of a chintzy little push switch, but it is a mechanical, switch. Got your little beeper here. Let me grab the flashlight, get us a little better look in here. Or better yet, if you bear with me a second, I'll get the microscope out. We'll take a little look, see what we can make out on the board and see if we can find some other interesting things to look at here. So give you a little better look there in this camera, but I'm going to be switching over to the magnifying glass at this point, or the microscope. I'm going to be switching to the microscope at this point. So let's see what we can see. A lot of surface mount there. This looks, they have lasered off the ICs. That doesn't surprise me. They love to do that. They're so worried someone's going to copy them. They don't mind copying everybody else in the world, but boy, they don't want you copying them. What do we got here? Probably an op amp would be my guess. Would make sense. Can't quite make out what we got. Here we go. 358. I'm going to bet money that's an op amp. Is that flux on the board right there? Maybe. Maybe a little flux left there. Over here. Didn't clean it up exactly perfect when they cleaned it. There's another die. Yeah, they got a lot of flux on the board. This board didn't get cleaned very well. I haven't told you what I paid for this, by the way. I picked this up for about 50 bucks with free shipping from AliExpress. You can pick them up, I think, for a little under that, but I think you have to pay shipping then. So they want roughly about 50 bucks for one of these. All in all, for what I expected, it's about what I expected. It's not like a super wow. It's an amazing build. It's a fantastic piece of equipment. It's a very rough built, cheap to the max unit. And it does what it says. It's got your super colorful, cartoonish display piece. The screen, I got most of went ahead and cut the rest of the screen plastic off. Let's get up there a minute. But the screen's not perfect. Needs to be cleaned now that I've done that, but it's got little micro scratches you might be able to make out there. Here's what I'm talking about. See these little scratches? That's not the kind of thing you'd expect if you were buying a Fluke or an Agilent or even a Siglent or a Rigel, but this is if you want a very basic, something you don't use often, you're going to bang around on the bench with it a little bit, you just can't justify spending big bucks. Will this work for you? Yeah, it'll work for you. So that's the MD-150 electronic load tester. Is it the finest piece of equipment that I have ever laid my hands on? Absolutely not. If you're in a serious lab environment where you're having to certify things, I don't think this would be what you'd want to be using. But in this case, for something I'll use once in a while. It's got more capacity, many times more capacity than the little one I had, which I paid half as much for. So this is twice the price, but 10 times the load capacity. I can see this be a handy tool for me. It will work perfectly in my lab where we're not looking for extreme precision calibration. That being said, the only thing I would say is it is Chinese cheap built, as I've shown. So if you decide to use this in your lab, the one thing I do want to warn you is I don't think I would have this pulling a lot of current from anything over long periods of time unsupervised. I'd be leery of putting big battery packs on this thing, draining down large battery packs at high current rates for a long time. I wouldn't trust the quality of this to make sure that I don't create a house fire. You know, even with your thermocouple sensor, internal and external, I would be leery. I wouldn't trust my house to this by any means. But if you're going to be there testing circuits, maybe drawing down a small battery pack while you're there and can observe, keep an eye, then fine, this would be great. I just wouldn't put large battery packs and discharge them overnight while I slept in a house. I just would not call for that on this quality equipment. And I'll leave it at that. It's a decision you need to make. I'm giving you the information to make that decision should you buy. With that, I hope you learned something. I hope my information was useful and help you make a buying decision. And feel free to leave comments down in the bottom. Let me know what you think. Maybe you know something I don't know about this unit. Maybe you have some recommendations for our viewers that are better. Maybe there's a device better than this for this kind of money. Obviously, there's many better pieces of equipment, but not for this money probably. So with that, hey, thanks for tuning in. Hope to see you in a later video.